All right, so in the first proof here, again, I'll try to explain the information as I go through it. I'll try to give you justifications for why you think a certain way or strategies for approaching it. Right, so in this first one, if we were to label what we have, so we have TR and TP equal, so that's a set of sides that we know. And then it says that Q is a midpoint. So it doesn't give us direct information, but indirectly it tells us that these two sides are equal. And so we need to actually create a statement to represent that. So we do have to interpret that statement into an equation form to say that PQ is equal to QR. And its definition of, and you have to use the word that's provided. So because they used midpoint, that's what we're going to define it as. You can't say definition of bisect. Even though bisect and midpoint mean similar things, you have to use the term that's provided for you. Okay, so this gives us a second pair of sides as far as our three elements go. So we either need to find the included angles as being equal, or we need to find the other side as being equal. In this particular case, you can do either. And so I'm going to show you both of them. What most of you probably found was the fact that these two triangles share a common side QT. So you could say that QT is equal to itself, and that would be reflexive property. That gives you a third side, so a third pair of sides. So now you have all the elements you need in order to state congruence of triangles. So triangle PQT is congruent to triangle RQT. And the pattern that's fulfilled here is three sides, or SSS. And now, this isn't the only way, though, that you can approach this. If you didn't see this, or instead you saw or chose a different path, you could have. And that different path was the other pattern that works based on this information is the included angle. So angles 5 and 6. And it is possible to say that those angles are equal to each other. Angle 5 and 6 are in fact equal. We could have gone this route, because if you look at the whole triangle PTR, the outer triangle, those are angles that are opposite equal sides. And in a triangle, angles opposite equal sides are equal. Okay, so we could have said that the angles 5 and 6 were equal. That gives us our third pair of elements. In this case, the third pair, that angle is in between the two sides. That is a pattern that works. Two sides and the angle between is SAS. So we could have used either of these forms. So the blue or the purple would work just fine on that.